in the previous topic you learnt about the chloralkali process. I think it is a new word for you, chloralkali process. It is nothing but electrolysis of brine. Electrolysis of brine solution. Why do we call this one as a chloralkali process also? Now let us take the previous equation. When you take aqueous NaCl, aqueous means water is also involved. Okay? It is producing sodium hydroxide plus hydrogen plus chlorine. And we all know very well about sodium hydroxide is a base and also it dissolves in the water. Since the base is dissolving in the water, this is known as alkali. It is known as alkali. Any base which dissolves in water is known as alkali. Any base which dissolves in the water called alkali. So, sodium hydroxide is an alkali and chlorine is also produced. Alkali and a chlorine. In this reaction, sodium hydroxide and chlorine. Sodium hydroxide is the alkali and chlorine. These two are produced, which are known as chlorine and alkali. That's why it is called chloralkali process. Chloralkali process. Got it, children? Now, let us understand the different uses of the products formed in the chloralkali process. One among them is sodium hydroxide. Let us see the properties of sodium hydroxide now. Yes, sodium hydroxide is used in the preparation of soaps and the detergents and artificial textile fiber rayon preparation. So, in the manufacturing of rayon in the industries, we can use this sodium hydroxide. Similarly, in the paper industry, we use this sodium hydroxide, as well as in the purification of bauxite ore, in the extraction of bauxite, aluminium from the bauxite ore, this sodium hydroxide is used, as well as this is used in degreasing the metals, dyes, and it is helping in the bleaches also. Now you have seen the uses of sodium hydroxide. Now let us see the uses of hydrogen. Uses of hydrogen. This hydrogen is used in the hydrogenation of oils. Hydrogenation of oils is nothing but generally when you take any fatty oils, fatty unsaturated hydrocarbons, in the presence of hydrogen, that will be changed into the saturated hydrocarbon, which will be nothing but the vanaspati or dalda. About this one you will be learning more in the next carbon compounds lesson. Okay, children? And next one is, it is used in the production of hydrochloric acid and it is used in the manufacturing of ammonia in the industries, and it is also used in making methanol. Methanol is one kind of alcohol which is very important ingredient in the industry, and it is also used as a rocket fuel. The liquid hydrogen is used as a rocket fuel. Now, till now you understood the properties of uses of sodium hydroxide and hydrogen. Now let us see the uses of chlorine. Yeah, uses of chlorine. This chlorine is used in sterilize the drinking water supply. You know very well about chlorination? Yes, this chlorine gas is used to kill the bacteria present in the water, which is nothing but the chlorination process. And this chlorine is used in the swimming pools. For what purpose? To clean the water and sterilize the water. And the next one, production of bleaching powder. In the manufacturing of bleaching powder in the industries, this chlorine gas is used. In the preparation of hydrochloric acid in the laboratories, this chlorine gas is used. And making PVC. PVC is nothing but polyvinyl chloride. As well as in the pesticides and CFCs. CFC is one of the important ingredients in the refrigerators and ACs. And that is produced from the chlorine. So, CFC is nothing but chlorofluorocarbons. Okay? And this is also used in preparation of chloroform. The formula for chloroform is CHCl3. And two more uses are, chlorine is used in the paints and dye stuff. Dye means which will be giving color to the different substances. That is nothing but the dye. In the cloth, for cloth also the color will be obtained with the help of this dye. Okay, so in the paints and the dyes stuff, this chlorine is used. and making solvents for dry cleaning. Solvent for dry cleaning is nothing but, you know very well, some of the stains for the cloth can't be removed by easy ordinary detergents. At that time that will be given for the dry cleaning, and some cloths also won't sustain in the hard detergents. At that time they go for the mild detergents, otherwise some other substances where that will not be having much effect on the cloth. So for dry cleaning purpose, the different substances can dissolve in the particular solvent. That solvent is nothing but one of the chlorine substances, chlorine products. Yeah, children, the products of brine solution we have seen now. Now, from the products of brine solution as well as the common salt, what are the different substances can be prepared with the help of this common salt, we are going to learn now. Out of those, the first one is baking soda. Yes, children? Yeah, how this baking soda is produced, that we can understand with the help of this small equation. And when NaCl is combined with ammonia in the presence of water and the carbon dioxide, it gives you sodium bicarbonate, NaHCO3. The common name for sodium bicarbonate is nothing but baking soda and ammonium chloride. This is called ammonium chloride. Clear, children? Once again listen. Baking soda is produced from common salt along with ammonia. Ammonia, water and carbon dioxide, when combined with the sodium chloride, this is giving you sodium bicarbonate and the ammonium chloride. This sodium bicarbonate common name is nothing but baking soda. The uses of baking soda in our day-to-day life, let us see now. Yeah, children, baking soda is the common name, and actual name is sodium bicarbonate. And NaCl combined with ammonia, water and carbon dioxide gives you ammonium bicarbonate and ammonium chloride. The uses are, it is used as an antacid. You know very well about antacid. You might have experienced when you go for any function or when you have very heavy diet, very heavy oily food or any of the spicy food you have taken. At that time you feel very burning sensation in your stomach. That means to digest the food, the body is secreting so much of acid. So it is imbalanced. In such case you feel very much of acidic. Acid is produced means it must be neutralized. How it will be neutralized? With the help of base. That base is a sodium bicarbonate. This will be used in the antacids. Means the tablet which will be acting as an anti-acid, that is nothing but the antacid. Okay, children? And it is used in preparing the baking powder. Now you may get a small doubt about baking soda and baking powder. There is a mild difference between the baking soda and baking powder, and baking powder is nothing but it is acidified baking soda. A small amount of tartaric acid is added into the baking soda, then that will be becoming as a baking powder. This baking powder is used in the food purpose. In the food also, generally if you take anything which you wanted to get very fluffy and all those, otherwise the cakes, in the bakery cakes will be produced. Yes, to make it very fluffy and all that, they use the baking powder. This baking powder is produced from this baking soda. Okay, and one more very important uses is soda acid fire extinguisher. So generally if you observe in any of the malls and all those places, film theatres and malls, some cylinders are placed. Even in our school, in the corridors or the staircases, you might have seen dry carbon dioxide powder sometime. Otherwise, olden days we generally use the soda acid fire extinguisher. So the baking soda combining with the sulfuric acid to produce carbon dioxide gas. This carbon dioxide gas is having the property of putting out the fire. So that's why this baking soda is used in soda acid fire extinguisher. Thank you. Yeah. So about the baking soda you understood. Next one is the washing soda. Washing soda is produced from the baking soda actually. And you know from the previous equation, baking soda is produced with the help of sodium chloride, ammonia, water and carbon dioxide. It is giving you the baking soda plus ammonium chloride. And from this baking soda, when you take this baking soda, this baking soda when you are taking NaHCO3, when you heat this one, okay, this itself you can get the information from this delta symbol. You, instead of writing this heat, if you write that delta symbol also, it is known as the heating only. So when it is heated, you will get Na2CO3 plus CO2 plus water. Clear? And here this is the sodium carbonate. This is called sodium carbonate. Another name for the sodium carbonate is soda ash. Okay? But this is not washing soda. Washing soda is decahydrated sodium carbonate. That means when you take this soda ash is sodium carbonate with 10 water molecules. If you combine, then you will get Na2CO3 10H2O. 10H2O, which is nothing but washing soda. So this washing soda is obtained from the process of baking soda itself. And what is the main ingredients? Sodium chloride, ammonia, water and carbon dioxide. From this you get sodium bicarbonate. When you take the sodium bicarbonate and heat that one, it will be giving you sodium carbonate, carbon dioxide and water. This sodium carbonate, when we combine with the 10 molecules of water, it gives you Na2CO3 10H2O, which is nothing but decahydrated sodium carbonate, which is nothing but washing soda. Now let us see the uses of washing soda. Washing soda. So this washing soda is produced by these three equations involved here. And the uses are, it is using as one of the cleansing agent. You know very well, cleansing agent is nothing but washing the clothes and everything. Yes, it will be helping in cleaning up the clothes and all. It removes the stains. And the next one is to remove the permanent hardness of water. You know very well water is getting the permanent hardness because of the presence of sulfates and chlorides of calcium and magnesium. If you heat that water, that will not lose its permanent hardness, but with the help of this washing soda, that permanent hardness can be removed. So that is possible with the help of washing soda. And the next one is, it is used in the preparation of glasses, soaps and the paper industry. And it is also used in the borax, in the preparation of borax powder, it is used. So the different compounds we are getting from the common salt. Here we are getting one more substance from the chlorine. This is nothing but the bleaching powder. What is the substance we are getting from the chlorine? Bleaching powder. How do we obtain the bleaching powder in this series? Let us see. Okay? And you know very well about calcium hydroxide, benoate. When it is treated with chlorine gas, it produces calcium oxychloride and water. When calcium hydroxide is treated with the chlorine gas, it produces calcium oxychloride and water. The calcium oxychloride other name is bleaching powder. Bleaching powder. Clear, children? Now what are the uses of this bleaching powder? The uses of bleaching powder are, the first use is, it is used in linen and cotton industry to bleach the pulp, wood pulp and the cotton pulp of the different substances, raw material. And it is used in the laundry to remove the stains or other dye color or anything, to make the color of the cloth very bright and very good. We generally depend on the laundry. In the laundry, the bleaching powder is used to remove the stains and all. And it is used in the disinfecting drinking water. This bleaching powder is generally containing of, see the formula, it is having calcium, oxygen and chlorine. When it is dissolved in the water, it produces chlorine gas. This chlorine is having the property of killing off the bacteria present in the water. That's why it is used in the disinfecting drinking water. And it is used in the manufacture of chloroform, which is nothing but the CHCl3. And it is used in making wool unshrinkable. Generally, wool if you take, it will be always shrinking. Okay? To overcome that problem, generally they treat that one with the help of bleaching powder, so that will be becoming straightened. And it is also used as one of the oxidizing agents in the chemical industry. Okay children, oxidizing agent is nothing but which helps in oxidizing something. it helps for the other one to get oxidized. Is nothing but the oxidizing agent. Thank you. Yes, children, one of the very important industrial components we are going to learn now. That is nothing but pop. What do you mean by pop? Is it popcorn? No, POP, pop. And you know very well, everyone in the life sometime they might be experiencing visiting the orthopedicians. And when you visit the orthopedician, if anyone is having the fractures, at that time the orthopedician tries to fix the fractures and everything properly with the help of one type of powder. What is that powder called? Pop powder. That powder is nothing but plaster of Paris. POP. Nothing but plaster of Paris. Why it got its name like this, do you know? First time it is identified and found and prepared and used by the people in the Paris. That's why the name is given as the plaster of Paris. Why the plaster? It is just like a plastic and it is sealed. That's what is known as the plaster of Paris. Okay? So how the plaster of Paris is prepared, let us see. This is prepared from gypsum. CaSO4 2H2O is nothing but the gypsum. And on heating, if we remove, how many molecules of water is there? 2 molecules. If you remove 1.5 molecules from it, then you will be getting CaSO4 half H2O plus 1.5 water molecules. This is nothing but POP, plaster of Paris. This is called gypsum. What is it? Gypsum. Yes? Yeah. And this is the plaster of Paris. What are the different uses that we are having the plaster of Paris? Yes? Plaster of Paris uses are many. Now let us see some of the uses that plaster of Paris is having. The uses of plaster of Paris are, it is used in the hospitals to fix the fractured bones, and it is used in making toys, decorative material and cosmetics, and blackboard chalk pieces, charts and chalk pieces also it is used to prepare, and even cast for statues. The framework of these statues is nothing but the cast, and you might have seen so many things on the roads during the Vinayak Chaturthi, nothing but Ganesh Chaturthi time. They prepare the idols with the help of this POP only. The framework is there. With the framework they prepare with the help of this POP. Okay, and the next one is fireproof material also will be prepared with the help of this. And the last one is it is used in the ceiling as well as air gaps in the apparatus. Generally, you know very well about in the laboratories, if any gaps are produced, automatically with the help of this plaster of Paris it can be closed. So it will be used in the sealing of air gaps in the apparatus. And one more thing, when you are having the newly constructed house, immediately you may ask your parents, Daddy, shall we have the false roof ceiling? That is also with the help of the gypsum sheets as well as the plaster of Paris. Even for getting the smooth walls, we will be just using this plaster of Paris to get the smooth finishing and everything in the decoration of the houses. Thank you. Yes, children. So till now we have seen the different substances which are produced from the products of brine solution. Okay, what are those substances? The first one is baking soda, second one washing soda, and third one is bleaching powder, and the fourth one is plaster of Paris. Okay, and now let us understand water of crystallization. What do you mean by water of crystallization? If you see, really the salts, crystal salts, do they really dry? No, they have the water content with them. And the color of the crystals also and the structure of the crystals also acquired by the water molecules present in them. Okay? For example, the best example we can take is copper sulfate. And actually the formula of copper sulfate, we used to write just CuSO4, but it is wrong. The copper sulfate actual formula is CuSO4 5H2O. Because of these 5 water molecules with the copper sulfate, its color will be in blue color and it will be in the crystal form. Okay, that's why it is called water of crystallization, and this salt is known as hydrated salt. What do we say? Hydrated salt. The salt which contains water molecule in it, and because of that water molecule, when that salt is getting the structure and the color, it's not required that every salt should get the structure, and it's not that every salt should get the color, but some will get the structure, some will get the color based on their properties with the help of this water molecule. Okay, we take one more example. Iron sulfate, FeSO4 7H2O. This iron sulfate color is light green color. Okay, and it is also a crystal. The crystalline nature is acquired because of this water molecule, and also it is acquired the light green color because of this. And children, you will be surprised to see if you take some amount of copper sulfate into a test tube and if you heat that one, the color of blue will be disappeared. You can get the white colored copper sulfate. That means the water molecules will be separated, and you can observe those water molecules in a test tube on the surface. Suppose if it is the CuSO4 5H2O and actual color is blue color. This is completely blue color. Okay, but when it is heated with the help of spirit lamp or something, automatically this blue color will be disappeared, and you can find water droplets inside walls of the top part of the test tube. This is because of the water molecules present in this copper sulfate getting evaporated, and this copper sulfate is becoming white color. How it changes? White color. Again, when it gets cooled, and if you drop one more or two drops into this white colored powder, this copper sulfate will get back its actual blue color. That shows that copper sulfate is not the dry crystals. It is containing a water molecules with it. Like that in the previous examples, washing soda, if you observe, Na2CO3 is not called washing soda, I said. Na2CO3 is not the washing soda. It is, the washing soda is nothing but 10 water molecules also contained with it. Okay, this is the decahydrated sodium carbonate, which is nothing but the washing soda. So this is about water of crystallization. By this, acids, bases and salts lesson completely over, and you just work on the textable question and answers and exercise questions which are given in that, and practice them. See the videos again and again until you understand, and read the textbook completely and thoroughly. Complete your work. Thank you. Have a great time.